Welcome back to my channel and thank you very much for joining another amp dyno video. Today's victim of torture testing is an amplifier made by MTX in 1994, the Thunder 2160. And the amplifier is rated 80 watts per channel into 4 ohms and 160 watts per channel into 2 ohms with low THD. They also published the dynamic power. The power rating was 425 watts of dynamic power into a 4-ohm load bridge mono. The amplifier came in here and I bought it used, but the amplifier wasn't working. I opened up the amp and what I found there was 3 broken legs. I fixed this amplifier and now it is working and we can start the amp dyno. Here you have the RCA inputs and you can make your power connections. The amplifier is fused 60 amps in total. Here is the gain knob and you have a switch where you can activate a low pass filter which is at 80 Hz and 18 dB of slope, and you have a Thunder EQ which has a center frequency of 40 Hz and a boost of 18 dB. And now let's get this thing dynoed.
The MTX Thunder 2160 is connected to the dummy load and I start as always with an 8 ohm mono load. That means I am testing 4 ohms per channel, both channels driven. Continuous power test 1 kHz. I got a peak voltage of 60 volts and it's confirmed. With 60 volts of peak voltage, the amplifier delivers 115 watts of continuous power into a 4 ohm load, both channels driven. Continuous power test with 50 Hz. Some clipping, I reduce my input signal voltage. Then we have it. It looks nice. It says also 60 volts maximum voltage. And I can confirm 60 volts. So the amplifier also delivers 115 watts into a 4 ohm load, both channels driven. At 4 ohms per channel, I checked for some dynamic headroom, but the amplifier delivers no dynamic headroom. I guess it will do at lower impedances. I have 1 kHz, 1 millisecond, 8 millisecond, 20 millisecond and even the 50 Hz burst test. The amplifier is doing 115 watts. Let's have a look at the amplifier's efficiency. Here we have the idle current, it's about 0.9 amps. And now I give full power 1 kHz continuous. And we have 30.2 amps. The amplifier has an efficiency of 56%. Now I connected a 4 ohm mono load, that means I test 2 ohms per channel, both channels driven, and I start with continuous power 1 kHz. Try to get some more. It goes into clipping. And it says we have a peak voltage of 58.4 volts. But I'm going to take 57.6 volts. The amplifier delivers around 212 watts into a 2 ohm load per channel, both channels driven. Let's have a look how many amps the amplifier pulls out of my power supply. 56.5 amps. Let's take 56.4. The amplifier's efficiency is around 56%. Continuous power test with 50 Hz. There it is. It says 60 volts, but that's not true. This is what we can take. There's some voltage there. 56.4 volts. The amplifier delivers around 204 watts into a 2 ohm load of continuous power, both channels driven. Now I'm going to do a 2 ohms mono test. That means I test 1 ohm per channel, both channels driven. But I will just test dynamically because the amplifier is fused with 60 amps. I pull more than 50 amps if I do a continuous power test into 2 ohms per channel. And of course my fuses are going to pop. The dynamic power test is a way lighter load for the amplifier's power supply. Dynamic power test 1 kHz, 20 cycles. We have almost all cycles at the same voltage level. Let's calculate with 48.4 volts. Dynamically with 20 cycles, the amplifier delivers 293 watts into a 1 ohm load per channel, both channels driven. Dynamic power test with 8 cycles, 1 kHz. There we have it. It says 49.2 volts. I'm going to inspect these waveforms. And there we have 49.2. Go to the last one. Also 49.2 volts. The amplifier delivers 303 watts of dynamic power with 8 cycles into a 1 ohm load per channel, both channels driven. Short peak power test for 1 millisecond, 1 kHz. 1 ohm per channel. We have some distortion. 53.2 volts. For just 1 millisecond with 1 kHz, the amplifier delivers almost 353 watts into a 1 ohm load per channel, both channels driven. Dynamic power test, 50 Hz, 10 cycles. As I said before, I always ignore the first 2 cycles, but we are free of clipping, especially on the last cycle. That's important in my opinion. We have 46.8 volts. With 10 cycles, the amplifier delivers 273 watts into a bridged monoload, 2 ohms. That means 1 ohm per channel. Now I'm testing 5 cycles. We have a peak voltage of 47.6 volts. With 5 cycles of 50 Hz, the amplifier delivers 283 watts per channel into a 1 ohm load, both channels driven.
Thank you very much for watching and see you next time for another dyno video. Stay tuned!